Alright, you already know we're out here. No need for no introduction. You already know what it is. Question 1A. You got cos theta, yeah? Plus I sine theta, yeah? How do you pattern that? That's the question. That's a nice little question. You know what I'm trying to say, yeah? You're gonna obviously apply the De Moivre theorem, yeah? And put the 6 into there, you get me? So it's gonna be cos 6 theta, yeah? Plus I sine 6 theta, yeah? So what you can do is you can just put the power inside, you get me? So yeah, that's how you pattern that one, you know what I'm saying? If you man didn't know, yeah? Alright, calm. Part B. Again, yeah, so cos 3 theta plus I sine 3 theta, yeah, and my man is going to be to the power of 4, yeah. So what you need to do, just put the 4 inside, yeah, so cos 12 theta, yeah, plus I sine 12 theta, yeah, calm. You know what I'm saying? Give it a little tail like that, yeah, and then you're pattern. Alright, calm. See, calm, see, yeah, so, alright, cool. So you got cos pi over 6, yeah, plus I sine pi over 6. And that's the power of 5, yeah? So again, the 5 is going to come down, you're going to times it inside, yeah? So cos 5 pi over 6, yeah? Plus I sine 5 pi over 6, you see that? Yeah, you see what I done there, yeah? Alright, calm. And then because there's actual numbers here and that, yeah? You want to just put this in your calculator, yeah? If you go into complex mode, yeah? If you click menu and then 2, you can enter this little thing here, yeah? And it should give you the answer of minus root 3 over 2 plus half I, yeah? If you don't know how to do that, then look up in it. Get to know, fam. Alright, D. Again, yeah, so cos pi over 3, yeah, plus I sine pi over 3. And you're going to do that to the power of 8. It's a bit of a mad one, yeah, but you want to do it to power of 8, yeah? That's going to give you cos 8 pi over 3 plus I sine 8 pi over 3, yeah? Calm. And then what that's going to give you, yeah, is it's going to put in the calculator again, yeah, it's going to give you minus 1 over 2, yeah, plus root 3 over 2. I, yeah? Pattern. E. Already on E, you know. Fast track, yeah? Fort Park thing. Cos 2 pi over 5, yeah? Plus I sine 2 pi over 5, yeah? To the power of what? 5, yeah? So you already know, yeah? Obviously, what's that gonna do, yeah? It's gonna cancel. When you times the 5 inside, it's gonna cancel that, yeah? Because 5 over 5 equals 1, you get me? So that's gonna be cos 2 pi, yeah? Plus I sine 2 pi, yeah? And obviously, for you man out there that know, yeah? If you know about this, yeah? Then you know about this, you get me? If you don't know about this, you don't know about this, yeah? But cos 2 pi is just 1. And sine 2 pi is 0. So it's going to cancel out the imaginary term, yeah? It's going to give you 1. You see that? If you don't know that, then just put it in the calculator. It will give you the same answer, yeah? IF cos pi over 10, yeah? Minus I sine pi over 10, yeah? So what you can do with this one, yeah? Is you can bring the minus inside, you get me, into the sign, yeah? If you've been looking at the previous exercises here, you know about that, yeah? So I can become minus pi over 10 here, yeah? Plus I sine minus pi over 10. You get it? And then what you can do, yeah, is that's the power of 15. So now just times the 15 inside. You get me? Calm. So that's going to be cos minus 15 pi over 10, yeah? Plus I sine minus pi over 10, yeah? Minus 15 pi over 10, yeah? Furthermore, yeah? You get that? So now what? That's it, fam. You get it? So now you want to just put it inside the little calculator, yeah? And what you'll get is you'll see this simplifies to minus 3 over 2, yeah? And minus 3 over 2, yeah? So it's just going to be I, yeah? Calm, pattern, different, yeah? Too easy. You know what I'm saying? That's what they call me, man. It's too easy. You know what I'm saying? Ah, calm. I ain't complaining. You know what I'm saying? I'm 2A. Said this meant to be further maths, yeah? Further maths, please. Question 2A, yeah? What's my man saying? He's saying, let me just double check the little question, yeah? What's he saying? Question 2A, yeah? Alright, calm. So what you want to do is you want to turn the top thing, yeah, into a exponential form, yeah? So at the moment, it says cos 5 theta plus I sine 5 theta, yeah? So that's just the same as I e to the power of 5 theta I, yeah? And the bottom one is cos 4 theta plus I sine 4 theta, yeah? So again, you want to just turn that into e to the power of 4 theta I. And now if you deep it, 5 minus 4, yeah, that's just 1, yeah? Because when you divide the indices, yeah, you minus them, yeah? So 5 minus 4 is 1, yeah? So it's just theta I, you get it? Calm. B. B, yeah, follows a similar format, they might say, yeah? What I mean by that is obviously you're going to change the cos 2 theta and the I sine theta, 2 theta to 2 theta I, yeah? And then over e to the power 4 theta I, yeah? That's obviously just from the, cos 2 theta, sine 2 theta, cos 4 theta, sine 4 theta, yeah? That's the last time I explained that, yeah? Calm. And what's the power saying? It's 7 and 3 if you look at the question, yeah? So hence, what can I do, yeah? When you have exponentials, like powers, indices, yeah, and a bracket like that, yeah? You times them in it, so it becomes e to the power 14 theta I. And that's over e to the power of 12 theta I. 14 minus 12 is 2, yeah? So e to the power of 2 theta I is the final answer, yeah? Do you see that? Do you see what occurred there, yeah? Alright, calm. Just extend that a little bit, yeah? Make it known. Yeah, make it known what's been there, you know what I'm saying? I see. So this is essentially just 1 over, again, cos 2 theta plus I sine 2 theta is just equal to 2 e to the power of 2 I theta, yeah, whatever, yeah? Easy, yeah? Power of 3. So that's just 1 over e to the power of 6, yeah? Because you times the power, yeah? Now, 1 over something, yeah, if you remember in indices, 1 over something to the power of something becomes just that something to the power of the minus of that something, you get me? So 1 over e to the power of 6 theta I is equal to e to the power of minus 6 theta I, yeah? If you remember that, like 1 over x is equal to x power minus 1, yeah? Alright, calm. D. Alright, D, yeah? D is saying a similar situation. So 2 theta I, yeah, to the power of 4 over e to the power of 3 theta I to the power of 3, yeah? And then again, 4 times 2 is 8, yeah? So 8 e to the power of 8 theta I over e to the power of 9 theta I, yeah? And that's obviously 8 minus 9 is just minus 1. So that's obviously going to give you what? E to the power of minus theta I, yeah? Which should also be equal to 1 over e to the power of theta I, but it doesn't matter, yeah? Alright, go on. E to the power of 5 theta I, yeah? Over e to the power of minus 3 theta I. Okay, let me explain that one, yeah? Before we get a bit wild in here, yeah? Let me explain how I achieved that, yeah? The way I achieved that, or the way I found that, yeah, is basically it says obviously cos 3 theta, yeah, minus I sine 3 theta, yeah. So obviously you bring the negative inside, you get me? So it'll become cos, and this 3 theta turns to negative 3 theta as well, yeah, because it got to be the same thing in both of them, yeah. Plus I sine negative 3 theta, you see that? And now deep it. If I put this in exponential form, what's it going to give me? It's going to be e to the power of minus 3 theta I, you see that? So on the bottom here, we've got the mouse is tweaking, fam. What's going on with the mouse, man? It's going crazy. Alright, calm. It's gonna be e to the power of minus 3 theta I, yeah? Squared. Calm. Squared because obviously the cos swing was squared as well, yeah? Alright, calm. That's e to the power of 5 theta I over e to the power of minus 6 theta I, yeah? And 5 minus minus 6, because division, yeah, minus minus here is gonna equal e to the power of 11 theta I, yeah? So that's actually the final answer, yeah? That's the definitive, yeah, of that question, yeah? Alright, calm. F. Calm, bro. F here. F again. Switch the top here. I think we got the hang of it now. That should be e to the power of minus theta I. And the bottom here is going to be the same thing. So e to the power of minus 6 theta I, yeah. And minus 1 minus minus 6, that's minus 1 plus 6, which is basically e to the power of 5 theta I, yeah. Calm. Question 3a, yeah. I think this is the Buki one, yeah. Let me check. Yeah, so in the book here, it's negative on the top and positive on the bottom, yeah. But in the solution bank and in the back of the book as well, yeah, it's positive on top and negative on bottom, yeah. So I'm just gonna take it at face value, yeah, and say it's like that, yeah. I think that's a mistake in the book. If I'm wrong, then it is what it is, bro. Just go pattern it, man. You know what I'm saying? Alright, so obviously, yeah, negative's gonna go inside, and negative's gonna be here. It's equals, of course, 7 pi over 13 plus I sine 7 pi over 13 power 4 over cos 4 pi over 13, but negative, yeah? Plus, put a little bracket if you wanna, you know what I'm saying, make it clear, yeah? Plus I sine negative 4 pi over 13, yeah? So easy, you know what I'm saying? Calm. And that's the power of what exactly? That's the power of something. Who knows, man? Yeah, power of 6. And then basically, yeah, used the Mowry theorem, yeah, to basically put the 4 down into there. So that's gonna become cos 7 times 4 is 28, yeah. So 28, yeah. You know what I'm trying to say? 28 cos 28 over cos 28 pi over 13, yeah. Plus I sine 28 pi over 13, yeah. Calm. Yeah, easy, man, yeah. And then put the 6 down there, yeah. 4 times 6 is actually 24, if you know that, yeah, from elementary maths. That's going to be minus 24 pi over 13, yeah. Plus I sine minus 24 pi over 13, yeah. So what I did there was bring the power inside times it, yeah. Alright, calm. And now what you want to do, yeah, is literally just put that into the exponential form. So the top is going to be e to the power of 28 pi over 13 I. And then the bottom is going to be what, fam? It's going to be e to the power of minus 24 pi over 13, yeah. I. So then 28 pi over 13 minus 24 pi over 13, yeah, that's going to give you e to the power of 52 pi over 13 I. And if you put that in your calculator, yeah, you actually can't put like an exponential with I thing in your calculator, yeah. You need to convert that into the cos and sine form, yeah. But that will give you 1 essentially. Calm. B. Calm. Let's pattern this here. B. What's B saying? B saying a situation, yeah. Basically, yeah. What you have to do for B, yeah, is if you clock this, yeah. What you have to do here is basically you have to get both of the things the same. And a way to do that, yeah, is to do this. Straight away, yeah, off the bat, yeah, it's negative in the middle, yeah. Let's just bring the negative inside straight off the bat, yeah. We don't need to even, you know what I'm saying, go through that. You know what I'm saying? I sine minus 11 pi over 7, yeah. Calm. And then 3. Calm. And now, yeah, and the bottom will be the same thing, yeah. What we have to do for the top here, let's just pattern the top first, yeah. The top basically, yeah, would become what? This minus 11 pi over 7, yeah? By the way, actually, minus pi 3 pi over 7 and pi 3 pi over 7 is the same, yeah? Cos x and cos minus x is the same, so I can get rid of that, yeah? But the negative here, yeah? What you need to do now is you need to do minus 11 pi over 7 plus 2 pi. And if you do that, yeah, because sine repeats itself every 2 pi, yeah? So you can add 2 pi and take away 2 pi as you wish, yeah? In order to achieve the same state, yeah? So therefore, if I add 2 pi to that, yeah? It will actually give me 3 pi over 7. So that's what we need to do here, actually, yeah? So it will be cos 3 pi over 7 plus I sine 3 pi over 7, yeah? And spin 3, yeah? Calm. And then the bottom's a similar thing, yeah? But this time instead of so we got 15 pi over 7, yeah, and again if you take away 2 pi from 15 pi over 7, you'll get pi over 7, yeah. So therefore you just take away that, so that's the common factor. So it's gonna be what? It's gonna be cos pi over 7, yeah, plus I sine pi over 7, yeah. So do you get you need the two angles to equal the same thing, yeah. And so but you need to do it using like a valid rule. You can't just do whatever you want, yeah. So you need to make one into the other, yeah. So you can just take away 2 pi from that, it will be the same as that, yeah. Calm. That's the power of what? Nothing. Of course not. Of course, there's always something, yeah. 2. Calm. That's easy now, yeah. Let's be real here, yeah. Let's not, you know what I'm saying? Let's not take ourselves for joke, man, yeah. Come on, yeah. So bring the 3 inside times the 3 there. That's cos 9 pi over 7, yeah. Plus I sine 9 pi over 7, yeah. Calm. And that's over what? Yeah, that's over cos 2 pi over 7 plus I sine 2 pi over 7, yeah. Calm. And now what you want to do is just convert it into a little form. By the way, you can also do this question using sine pi plus x here is equal to minus sine pi minus x, this rule, yeah. Look into that if you want, yeah. I'm not going to explain it right now because I ain't got time right now, you get me? But you know what they say, in it, time is money, money is time. But if you want to learn about that, then go look it up yourself. You can also do that question using this here. Calm. And yeah, so basically that's e to the power of 9 pi over 7 I over e to the power of 2 pi over 7 I, yeah? So 9 pi over 7 minus 2 pi over 7, obviously, use your brain. That's going to be 9 minus 2 is 7, yeah? So that's going to be e to the power of 7 pi over 7, yeah? Obviously, 7 over 7 is just pi, so it's just 1, so e to the power of pi I. Obviously, that's equal to negative 1, yeah? Oh, calm, chill. We're chilling, man. Calm. Question C, yeah? C's a similar situation, yeah? Again, bring the negative in, and you should be able to just keep adding 2 pi. So negative 2 pi over 3, yeah, plus 2 pi, yeah. And of course, that's 4 pi over 3, so you get the answer, yeah. But again, another way you can do this is, again, using that pi minus x thing, yeah. You can say pi minus x is equal to 2 pi over 3. So therefore, x is equal to pi over 3. So the pi plus pi over 3 was 4 pi over 3, but listen, man, doesn't matter, okay? We're just gonna do this a standard way, yeah. So cos what is it? What does it say? Cos 4 pi over 3. Obviously bring the negative inside, so that's gonna be plus I sine negative 11 pi over 7, yeah? What am I talking about? 2 pi over 3, yeah. And then again, yeah, obviously this should be negative as well, but you can just ignore the negative because cos x and cos minus x are the same. And obviously, yeah, add 2 pi to that, you get 4 pi over 3. So you can change this to 4 pi over 3, yeah? That's the whole trick here. You need to make them equal the same thing by either adding or minusing 2 pi, yeah? Calm. And now over what? Over 10 pi over 3 and 4 pi over 3, yeah? What's 4 pi over 3 plus 2 pi, yeah? I have a suspicion, yeah, that my man is gonna get 10 pi over 3, yeah? Calm. So yeah, just add 2 pi over 3 to 4 pi over 3 on the bottom, yeah? It will give you 10 pi over 3, so the bottom is clearly gonna be cos 10 pi over 3 plus I sine 10 pi over 3, yeah? That's just the situation, yeah. That's just the way things are, you know what I'm saying? Sometimes you just gotta take what's given to you and you just gotta use that as the resources, you know what I'm saying? You get me? So you get that, yeah. Alright, go on. This obviously to the power of something, yeah. It's the power of 7 and 4. So maybe should have done that. Calm. And then obviously times the 7 inside, times the 4 inside, yeah, it's getting pretty repetitive here. So that's cost 28 over 28 pi over 3 plus I sine 28 pi over 3, yeah. But it's good when it gets repetitive, yeah. That means that it's getting easy, you know what I'm saying? And in terms of 4 inside, yeah, that's cos 16 pi over 3 over plus I sine 16 over pi over 3, yeah, I believe. Calm. And then obviously convert that way into like a reasonable factor. So the top's going to be e to the power of 2e 28 pi over 3 I, and the bottom's going to be e to the power of 16 pi over 3 I, yeah? Then 28 pi over 3 minus 16 pi over 3. That's 12 pi over 3, so e to the power of 12 pi over 3 I, and again, if you put that in a calculator, it'll give you 1, yeah? Not how it always just simplifies to like 1 or negative 1 or something. Alright, go on. Question 4a, yeah? Okay, this is where you got to start thinking, you got to start using the medulla oblongata, yeah? Question 4a. 1 plus I to the power of 5, yeah? So listen, man, let's just take a 1 plus I. Let's just take that, yeah? 1 plus I. Forget about the power of 5, yeah? What's R? R is equal to 1 squared plus 1 squared divided by square rooted, yeah? So that's root 2. Calm. What's theta? Well, theta is equal to tan inverse, yeah? Of 1 over 1, yeah? Because obviously, and that's power over 4, yeah? Because obviously what? Because obviously this is 1, so it's just 1 over 1, yeah? Calm. And there's no negatives or anything, yeah? So hence, yeah, the 1 plus I can be written as root 2 e to the power of pi over 4 I. And then we want to 5, put that to power 5, yeah? So that's going to be root 2 to the power 5, if you put in your calculator, yeah, it's 4 root 2. E to the power, and then you just times the power, so 5 pi over 4. You get it? Yeah? Easy. And then if you actually work this out, yeah, that'll be 4 root 2. And then just write the cos 5 pi over 4 plus I sine 5 pi over 4, yeah, that shall write as well. It's minor, yeah. Obviously, just put this in the calculator, it will simplify to minus 4 I, yeah. Come. B. Minus 2 plus 2I, yeah, to power of 8. Again, this is a similar situation, yeah. Find R first, yeah. R again, so forget about the power of 8, just do minus 2 plus 2, yeah. The R here is 2 squared plus 2 squared square rooted, yeah, that's 2 root 2. And then basically to find the angle, yeah, if you have the IM and the RE, or if you watch the previous videos here, you'll know that this is minus 2 and 2. So we want this angle, yeah. And what if we do tan inverse, we're going to find this angle. So we need to do this 1 pi minus the angle, yeah, to get the real angle that we want, which is here. Yeah. So tan inverse of 2 over 2. And we want to do pi minus tan inverse of 2 over 2. Yeah, that's going to give us 3 pi over 4, yeah. And so we got 2 root 2, yeah. E to the power of 3 pi over 4 I. And that's the power of that. I put I for that one. No, I didn't. Calm. And then that's the power of what? Power of 8, yeah. So again, just listen, man. It's not every day. You know what I'm trying to say? Yeah. Let's just be realistic here. That's 4096 here. E to the power of 2 4 pi over 4 I, yeah. Now listen, man. Just expand that into cos form and just put in your calculator, yeah. You'll get 4096 here. So this can equal 0, yeah. Not 0 1, yeah. Alright, calm. C. C. So for C, yeah, 1 minus I. Pretty easy. R is going to equal root 2. Again, I don't think we need introduction by now, yeah. 1 squared plus 1 squared square root, that's root 2. And then basically, yeah, that's going to be what? Like minus 1 minus 1, so that's just minus theta, yeah? So it would just be theta equals minus tan inverse of 1 over 1. That's equal to minus power 4, yeah? Again, if you're unsure about this whole thing, yeah, then just look at the previous video, you'll understand it, yeah? Alright, calm. So that's what? Root 2, yeah? E to the power of minus pi over 4 I, yeah? And again, what am I going to do here? I'm going to put that to the power of 6, yeah? Obviously, that's 8, yeah? Root 2 to the power of 6, 8 here. And then cos minus pi over 6 pi, obviously 6, the Moivre theorem, yeah? 6 times into there, minus 6 pi over 4. Then plus I sine minus 6 pi over 4, yeah? And then obviously just put that in the calculator, yeah? It will give you 8i. So that's the answer. D. 1 minus root 3i. So obviously, r is what? R is 2, because 1 squared plus root 3 squared, that's 4, and then square root 4 is 2. So r is 2, yeah? Found by Pythagoras here, and then again, we're in this situation here, so it's going to be negative tan inverse here of root 3 over 1. That's going to give you negative pi over 3, yeah? So that's theta, yeah? Alright, calm. So the thing is 2e to the power of minus pi over 3i, yeah? And obviously, if you pattern that, that's power of 6, yeah? Because the question is being part of 6 here, yeah? Alright, calm. And if you pattern that, yeah, it will give you, you just do 2 to the power of 6 is 64. Cos minus 6 pi over 3 plus I sine minus 6 pi over 3, that's going to give you 64, yeah? Calm. Yeah. So again, yeah, 3 over 2 minus root 3 over 2i to the power of 9. So let's just isolate this first, and then we put it in exponential form, and then you put power of 9. So that's just going to be what, yeah? That's just basically 3 over 2, and then negative root 3 over 2. So that's here. So again, it's just going to be a negative 3 plus equation, yeah? And then r is going to be square root of 3 over 2 squared plus minus root 3 over 2 squared, and that's going to give you root 3, yeah? So, and then theta is going to equal minus tan inverse here of root 3 over 2 over 3 over 2. That's going to be minus pi over 6 here. So we've got root 3 e to the power of minus pi over 6 here, I to the power of 9. And listen, man, again, times that in and whatnot, yeah. It's going to be root 3 cos minus 9 pi over 6 plus I sine minus 9 pi over 6 here. Root 3 to the power of 9, sorry, so 81 root 3, yeah. And that's going to give you an end 81 root 3, yeah. I. That's the final answer if you put that in your calculator here. Calm. As in put it in cosine form, yeah, and then put it in calculator here. Alright, F. Nearly done, yeah. F. Too many questions, man. They're getting better cocky with it, man. F, yeah, is what? Is minus 2 root 3 minus 2i, yeah? It's a power of 5. So pattern that, yeah? R is what? R is going to be equal to, you already know, man. Try this on your ones, actually, yeah? Try on your Jack Jones, yeah? Try to do 2 root 3, yeah? Squared plus minus 2 squared square root. That's going to give you 4, yeah? So basically, after that, yeah? Pi is going to equal what? So you might not know this one, yeah? But if man's down here, yeah? Minus 2 root 3. And I'm down here as well, yeah? Minus 2, yeah? Bang, yeah? So what's going to happen here, yeah? It's going to be minus pi, because that's that. Remember, if you go from down here, that's negative angle, yeah? So minus pi, but you want this angle here. So you're going to have to do minus pi plus this angle theta, if you understand? So when it's in that quadrant, yeah, to find the angle that you want, it's going to be minus pi plus tan inverse of the thing, yeah? 2 over 2 root 3, yeah? And always don't put the negative there, yeah? Like a negative inside the angle, yeah? That's equal to minus 5 pi over 6. And then, yeah. So it's just 4 e to the power of minus 5 pi over 6 here, power of 5 here. And then again, 4 to the power of 5, that's 1024. And then cos minus 25 pi over 6, you use the De Moivre theorem to do the 5 times in there, 5 times 5 25, yeah? Cool. And then we put that all in the calculator, you'll get 512. I think that's a 2 or 7, man. I'm not checking right now, yeah. Just double check on that, might be a 7, bro. Minus 512i. I can't really read my handwriting, you get me? So, listen, if it's a 2, it's a 2. If it's a 7, it's a 7, man. Just, you know what I'm saying? It is what it is. I might leave it in, like, a little bit obscure, yeah, so it can be both of them. Question 5. You might not watching this for the method anyway, not the final answer. You should be calculating the final answer, yeah? Alright, cool. Question 5, yeah. Express 3 plus I, whatever, whatever, in the form of that, yeah? So, again, yeah, it's the exact same thing. Literally nothing has changed here. We do 3 squared plus root 3 squared here, and then square root, and that's going to give you 2 root 3 here. And then on top of that, the all score, oh, can't even talk anymore, fam. It's crazy. Basically, yeah, 2 root 3, yeah, and then theta is equal to what? Theta is going to equal to tan inverse. This is just normal angle now, because we're in the positive quadrant here for both of them. It's equal to pi over 6 here, so it's just 2 root 3 e to power pi over 6i here, and then that to power of 5 here. Calm. And that's going to be 288 root 3 cos 5 pi over 6, because you'd use the De Moivre theorem, you times the 5 into there, plus I sine 5 pi over 6, yeah, 6. And then you just put in that calculator, you get minus 432 plus 144 root 3i, yeah? Calm. Question 6 here. Question 6, find the exact value of that 4. So it's just the same, man. You know what I'm trying to say? Like, just every single day is the same situation. Well, W is equal to what? 2 cos pi over 6 here, plus I sine pi over 6 here. And then obviously W4 is just going to be what? 2 to the power of 4 here. And then cos pi over 6 here, plus I sine pi over 6 to the power of 4, yeah? So obviously it's the same thing here. So 2 to the power of 4 is what? 16. And then times the 4 inside, that's cos 4 pi over 6, which is 2 pi over 3, plus I sine 2 pi over 3, yeah? And then again, put down your calculator, yeah, with the 16 open bracket, all of that, yeah, you get minus 8 plus 8 root 3 I, yeah? Calm. Question 7, yeah? Sept. Use that, yeah, find the exact value of z6, yeah? So again, you do the exact same thing, yeah? So z is equal to what? Root 3, open bracket, plus, again, bring the negative inside, yeah? It is always, yeah? Might as well do it in one step. Plus I sine minus 3 pi over 4 again. And then, yeah, all of that to, yeah, okay, calm. And then z to power of 6, yeah? It's just everything to power of 6. Root 3 to power of 6 is 27, yeah? And then cos whatever is going to be cos minus 18 pi over 4, because you want to do 3 times 6, which is 18, yeah? Plus I sine minus 18 pi over 4, yeah? And again, you put in a calculator, and then you get the answer of minus 27i, yeah? So this is probably minus 1. And the other thing is probably 0, yeah? Alright, calm. Question 8a. Question 8a, yeah? What's he saying? He's saying, yeah? Express that in the form of that. Okay, no problem. Well, my friend. 1 plus, yeah? I root 3 over 1 minus I root 3. Same thing. So 1 squared plus the root 3 squared is square rooted as 2, yeah? So you know it's going to be 2 here. And then tan inverse of root 3 over 1 is pi over 3. So 2e to the power of pi over 3i, yeah? So again, you just put it into exponential form, yeah? Again, same thing here. So 1 plus minus root 3, both in square, square root, that's again 2, because negative cancels when you square. And then what? And then tan inverse of root 3 over 1, but you can do negative of that, yeah? Because it's in the negative situation down here, yeah? Calm. So that's 2e to the power of minus pi over 3i, yeah? Calm. So pi over 3 minus pi over 3 is 2 pi over 3, and 2 divided by 2 is just 1. So e to the power of 2 pi over 3i is the final answer, yeah? What's B saying? B is saying, hence find the smallest positive integer value, yeah? Calm. So if you do here, e to the power of 2 pi over 3i, that's just cos 2 pi over 3 plus I sine 2 pi over 3, yeah? And now I want to find like what form of that, yeah, would make this real and positive, yeah? This and the smallest one as well. So what you put is you introduce an n variable, yeah, like 2n pi over 3, yeah, plus I sine 2n pi over 3, yeah. You'll see why in a minute, yeah. Calm. And that's obviously the same as e to the power of 2n pi over 3i, yeah. Calm, yeah. Now you want it to be positive, yeah, and you want it to be real, right? So it's real and positive. So if it's real, that means that the imaginary component needs to become zero. So it needs to basically cancel out. Do you understand that? When does sine become zero? Sine becomes zero when it's sine pi. Yeah? So you want, yeah, ideally, for it to be real, you want the 2n pi over 3, so this whole angle here, you want that to be equal to 2 pi. To equal to pi. Do you see that? Because that's when pi becomes zero. But that's when sine becomes zero, yeah? So you only get the real part left, yeah? And the imaginary part goes away, yeah? Because I times zero will become zero. So get rid of the imaginary, yeah? Get rid of I, yeah? So then think, what's n gonna be for it to equal pi, yeah? Well, n can equal 3 over 2, yeah? Because obviously for 2 times 3 over 2, 2 over 3 times 3 over 2 is gonna cancel, so it's gonna be pi, yeah, on the left, yeah? If you put 3 over 2 into there, yeah? But the issue with that, yeah, is if you put cos of, again, if you put that into cos here, so cos 2 3 over 2 pi over 3, it will give you -1, yeah. -1 is not positive, yeah. And the question asks for find the smallest positive integer value of n, yeah, for which is real and positive, yeah. So you want that the whole thing to equal real and positive. So this is going to equal -1, which is real, but it's not positive, it's negative, yeah. So as a result, you need to come back to here. I need to think what value of n would make this something else, right? So let's try n equals 3. That also seems logical because 3 and 3 are going to cancel. That will give you 2 pi. And 2 pi is obviously a multiple pi, right? So if 2 pi would also make the sign cancel. You get me? Because sine 2 pi is also 0, yeah? And so obviously you put 3 into here, yeah? That's going to equal 2 pi, yeah? And cos 2 pi is equal to what? Cos 2 pi is equal to 1, so it's correct, yeah? So that's the smallest positive real value is 1, yeah? And that is n equals 3. Yeah? And that will be 1, that will be very small, it will be positive, and it's also real, yeah? Alright, calm. Question 9, yeah? So use my man's theorem, yeah, to show that that plus that is real for all integers, yeah? So what you need to do here, yeah, for question 9, it's easy. Nice one to end it. A plus bi, yeah, can be written as r cos theta plus I sine theta, yeah? Why is that? Because sine theta and cos theta are just numbers, yeah? And times r is just a number. So A is also just a number, and B is just a number. So they're the same thing, yeah? And that can also be written as, because it's in the sine r form thing, can be written as r to e to the power of I theta, yeah? Calm. And A minus B, what do you think that can be written as? R cos theta minus I sine theta, yeah? Which again can be written as r e to the power of minus I theta, yeah? So hence, A plus B I to the power of n, as the question is asking you to do, plus A minus B I to the power of n is going to be equal to r to the power of n e to the power of ni theta plus r to the power of n e to the power of minus ni theta, yeah? Now, I can factor outside the r to the power of n, so it'll become r to the power of n e n I theta plus e minus n I theta, yeah? And I can expand the e to the power of ni theta, yeah? I can expand that into cos and sine form, yeah? So cos n theta plus I sine n theta. And then this one as well, plus cos n theta, yeah, minus I sine n theta. Do you see that? And then I sine n theta and and minus I sine n theta, that's going to cancel. So it's going to be r to the power of n, yeah? And then cos theta plus cos n theta, yeah, is going to equal 2 cos n theta, yeah? So that equals r 2rn cos n theta, which is real, yeah? Because the imaginary component has gone, yeah? So you've got 2 real, you get me? Come, yeah? So that's it basically, yeah? That's it. That's the end of the exercise. Easy.